Hello, let's look at how we can work with shared mutable state. And if you're like me and you've done a lot of Arc Mutex tutorials in Rust, you'll probably have come across the counter example. Now, that's fine, but you get to a point where you think, well, actually, I've done all these counter examples, but how do you actually use it, or what is the actual point? So I've had a little chat with Claude, and hopefully you'll forgive me because I believe this is actually a useful example. So what I've done was I've asked it to teach example of altering mutable state using Arc Mutex in Rust. Yeah, and then it did come up with the counter example to start with, which is fine, but just incrementing in I32 is not really my ambition in life. So I said, no, make it more real world with like a proper chat state. Now I'd seen, even in Actix Web, they'd done an example of shared mutable state. And even theirs was just incrementing in I32. But having read this on the Actix web page, made me realize that there was actually a bit more behind the scenes that I needed to learn. So, yeah, the combination of Actix Web and Claude and just my own curiosity has brought me here. So, our chat state struct to hold the application state. If you've seen a recent video I also did a video using WebSockets. And that was with Tokyo Tungstenite as well, and loads of other things. But I don't want to progress on to doing WebSockets with shared mutable state until I've actually nailed shared mutable state itself. So that's, as you can see here, std sync arc mutex standard thread. So that's just sort of standard library. It's not going off to the Tokyo side of things just yet. So shared mutable state, you've got messages, user presence, total message count. So again, it's good practice at building structs where you've got more than sort of just a primitive type. So you've got messages, which is a vec of strings, hash map, which is a string, user presence, which is a hash map, which contains a string and a bool. And basically, that's the user, I think it's another example. I was using the UUID version 4 for a user ID, but here it's the user name and a boolean to say true or false as whether they're online or not. Total message count. Now that's the total so that hash map has got all of the users and all of their online statuses. The total message count is obviously the message count of all of the messages that have been sent by everybody. So this is doing different things really. You've got total message count, so that's just what everybody contributes to. You've got user presence, which, yeah, again, everybody contributes to, but they're obviously either true or false, online or offline. And messages, that's what everybody. So it is all three of those things actually are just contributed to by every user. A bit further down, we'll be looking at the user being a separate or having their own thread. Well, in the main, they're simulating that using user one thread. Here, look, user one thread. And then you do arc clone, and that's cloning a reference. That's the key thing to really always remind yourself. You're not cloning the actual chat state. You're cloning the reference to it. And then at the end, as each thread completes, then the reference to it is dropped until you get down to 0. That's how I understand it. Okay, and then user 2's got their thread as well. So because it's another thread, it clones the reference, and because it's got a reference, it can then do, that's why you need to use mute. And then obviously the lock, you take the lock to let you work with it. And again, you see nothing's getting returned here. It's just being mutated in place. And then just the print switch you can do or leave out. That's not critical. So I think this is quite a nice example of how you can use shared mutable state with Arc, with Mutex, and clone for each thread. The implementation in main is quite contrived, so that's probably worth really not ignoring, but just just make sure you understand that that's attempting to simulate what would happen in a chat room. So what we'll do now is we can go across, and I'll show you. In fact, I'll show you what I cobbled together with the help of Claude. So whenever I do these videos, I will always say if I've used AI or ChatGPT or Claude or whatever, because I think it's been a bit disingenuous otherwise. So if we go to chat room, cargo run, I've already written this code. So chat service, that's how quick that was. That's amazing. And here we go, is a chat room. So the HTML is inside that binary. Hi. Mr. Moose says hi. And then Mr. Man says yo. And these will just keep building up. So each of these are obviously just getting added to, I think this code uses a vec of strings as well. Let's just go in here. I did this on Sunday and today's Tuesday, so I feel like I've travelled 1,000 miles in Rust world since then. In fact, if I do tree, it's actually got 3 files. Chat, handlers, main. Now, as I move forward, I want to become more adept at splitting code up and not just putting it all in main. I already do that, but I think also it's one of the key things or the key skills as you kind of move up through the ranks as a developer is to become more proficient at naming things more correctly. I think that's a real giveaway with sort of junior developers. Let's go to chat. So we've got the struct there, which is sender, content, timestamp. So it's a bit different to the example we were looking at in Claude. Chat state. So again, we've got a vec. So here, rather than a vec of strings, we've got a vec of chat messages. So you've got a struct inside a vec, inside a struct, if that makes sense. And cargo indexing. Excuse me. I don't know if that's a NeoVim thing or a Rust Analyzer thing or something. I don't know. Having said all that, my laptop's quite hot because I'm using OBS and just... Anyway, that's just another way to use chat state. I think chat rooms are quite a useful didactic learning tool because you've got the shared state. You're looking at threads, Arc, Mutex. It kind of brings it all together, really. I just want to look at this function as well, just to share this with you. And these videos are kind of to help others, but also to, from a selfish point of view, it's to make me learn, explain, and potentially, hopefully, remember some of this stuff. So what we've got here is we're looking for online users. Now, online users are, this is within the chat state impl. And chat state is what we looked at the start of the video. So we've got a new function, an add message function, user login, user log out, and then we've got get online users. And I think this is the interesting one because we're iterating over user presence. If you remember, if we go back up here, user presence is the hash map of usernames and whether they're online or not. So user presence is a hash map, and it contains user and the content. No, it doesn't. Sorry, I tell a lie. I'm looking at the wrong thing. It contains the username and then whether they're online or not. Of course it does. Okay, so iter, filter, map, collect. That's quite a common pattern in Rust. But this is interesting because, yeah, first thing is if you're not concentrating or you've got TV on in the background or something, you might forget to put, when you're passing in two things on the start of the closure, two things, tuple, remember the curly bracket, the parentheses even. And the underscore, you probably know that's kind of like the throwaway. It just means you have to put it in, but it's not going to be used later on. So unpack it, but don't use it. And there, we're unpacking, but not using the username, because we just want to find if online is true. And then, later on, we map. So then we're only dealing with the ones that passed this first filter. And then we take the username, because we only want username, and then we throw away the online status. Because we already know the online status, because we got it from the previous step. It's a really cool pattern, I think. It's a filter, map, collect, but use the underscore on the first part of the tuple there, and then you use it on the second part on the next line. So that's all I'm going to kind of run through here. The arc clone, I think you've probably, if you've done any arc mutex examples, you'll be familiar with the arc clone, but it's just more the using the chat state struct rather than just a counter and incrementing a counter, because you can increment a counter as much as you want, but the use cases for that are probably limited, or whereas shared mutable state, where you've got the chat state, I think that's, let's ask Claude actually. In the grand scheme of things, how often would a shared mutable state just be a counter? I think I know the answer, but it's interesting anyway. Compared to how often in production code shared mutable state would be more than just a counter. Give some sort of ratio. Yeah, so in production code, a simple counter is rarely the only shared mutable state you'll encounter. I'd estimate the rough ratio, 5% simple counters versus 95% complex shared states. Real-world shared mutable state typically involves complex data structures like our chat state example, 70 to 80% of cases, server connection pools, configuration settings, session data and memory caches, game state management, application metrics and telemetry, counters with additional context, 15 to 20%. Yeah, so the simple standalone counter that we all seem to come across. I guess the key here is what I'm probably trying to get at is just always look past the kind of didactic tutorial examples, because just bear in mind that you can nail those and memorize them in think you're doing well, but yeah, then real world smacks you in the face, and you have to kind of do something which is a bit more like server connection pools, configuration settings, so on. So the simple counter examples you often see are deliberately simplified to teach the concept without overwhelming you with domain-specific details. You're almost always dealing with significantly more complex shared state. This is why understanding how to properly design thread-safe data structures, like our chat state example, is such a valuable skill. It's the pattern you'll actually use in real-world concurrent Rust applications. And I know I've used Claude here, and I know it's AI, but I think in this case it's right. I think does everybody agree with that statement? Anyway, let me know. Thanks for watching the video, and I'll be back soon. And yeah, thumbs up, like, and all that stuff. Thanks.